Welcome to The Explainer. Today we're diving into a topic that, let's be honest, strikes fear into the hearts of so many programmers: dynamic programming. But here's the thing, we're going to demystify it. We'll break it all down and show you how to master it by thinking in patterns, not just trying to memorize a bunch of solutions.
All right, let me ask you something. I think pretty much every single person in computer science or software engineering has had this moment. What's that one topic that pops up in a coding interview or on a problem set and your heart just sinks a little? You know the one.
Yeah, for a lot of people, the answer is dynamic programming, DP, right? It just has this reputation for being, well, impossible. It feels like this huge, scary mountain of random problems you're just supposed to, magically know how to solve?
But what if I told you that's completely the wrong way to think about it? The secret isn't memorization at all. This quote from AlgoMonster just nails it. You don't need to memorize hundreds of problems. You just need to master a small set of patterns. It's about seeing the patterns underneath. And that, right there, is exactly what we're going to break down today.
Okay, so let's get our hands dirty. We're going to start with a classic problem. And on the surface, it looks pretty simple, almost innocent. But lurking inside is this hidden trap that perfectly shows why the obvious solution completely falls apart and why DP is such a game changer. So here's the deal. Picture a staircase with n steps. You're standing at the bottom, step 0, and you have two choices for every move. You can either climb one step or you can jump 2 steps. That's it. The big question is, how many totally different ways are there to get all the way to the top?
You know, the first thing that probably comes to mind is recursion, right? It just feels so elegant. I mean, the number of ways to get to the top step, let's call it n, must just be the ways to get to the step right below it, plus the ways to get to the step 2 below it. Simple. It's a beautiful idea until you actually try to run the code. Then you hit a brick wall. Hard.
And this right here, this shows you exactly why it breaks. Look at this. To figure out ways of 6, you need ways of 5 and ways of 4. Okay, makes sense. But wait, to get ways of 5, you also need ways of 4. So you're calculating ways of 4 twice already. And then look at ways of 3. It just keeps getting called again and again and again. Our function is basically an amnesiac. It does all this work and then immediately forgets it and does the exact same work all over again.
And this isn't just a little inefficient. This explosion of recalculation leads to something called exponential time complexity, O of 2n. Now that sounds technical, but what it really means is that the runtime just goes haywire. To put it in perspective, for a tiny staircase of just 30 steps, our elegant little function would have to run roughly 1 billion times. That's not just slow, it's completely, utterly broken.
Okay, so we've found the villain of the story. It's not our logic. Our logic is fine. It's the recomputation. And realizing that is the first step, because it points us directly to the fundamental structure of a DP problem.
So there's this fancy term for this. It's called optimal substructure. Don't let the name scare you. It just means that the solution to our big problem, getting to step n, is just built from the solutions to smaller, easier problems, getting to step n-1 and n-2. That's it. And you can probably see where this is going. If we could just solve each of those little problems once and just write down the answer somewhere, we'd be in business.
And that, my friends, is where dynamic programming finally enters the picture. It's not one single thing. It's basically a toolkit, and it gives us 2 amazing techniques to do exactly what we just said: solve every little problem once, and only once. This lays it out perfectly. The 2 big tools in our DP toolkit are memoization and tabulation. Think of memoization as our original recursive idea, but with a cheat sheet. It's top-down. Tabulation is the opposite. It starts from the beginning and builds its way up, bottoms up. They look different, but they're really just 2 sides of the same coin, and their one and only goal is to kill that wasteful, repeated work. So let's look at memoization first. We keep our recursive, top-down structure, but we add one simple, powerful rule. Before we do any work, we check a cache, like a little notepad, and ask, hey, have I already figured this out? If the answer is yes, we just grab it from the notepad and we're done. No more recalculating ways 3 a million times. We just look it up.
Tabulation, on the other hand, just flips the whole thing on its head. It works from the bottom up. Instead of starting at the top and breaking it down, we start at the bottom with the easy stuff. We make a little table. We know the answer for step 1, right? And step 2, we fill those in. Then we just loop, using those answers to build the answer for step 3, then use that to get step 4, and so on, building our way up one step at a time until we get to the top.
And this is the payoff. This is the whole point. By using either of these techniques,
We take that terrifying, explosive O to N complexity and we crush it down into a simple, beautiful, linear O of N. What does that mean? It means our runtime grows in a nice, predictable straight line. That problem that took 1 billion operations for 30 steps, now it takes, well, 30 operations. That's not just an improvement, it's a total transformation. That is the power of dynamic programming.
All right, so we did it. We totally cracked the staircase problem. But here's where things get really cool. The real magic isn't about solving this one problem. It's about realizing that we've just stumbled upon our very first major DP pattern.
This is called the constant transition pattern, and all it means is that the answer for where you are now depends on a fixed number of places you could have just come from. For our staircase, it was always the 2 previous steps, not 3, not 4, always a constant 2.
And once your brain clicks into seeing this pattern, you suddenly see it everywhere. You look at a problem that sounds totally different, like min-cost climbing stairs or the famous house robber problem, and you'll realize, wait a second, this is the same thing. It's just the staircase problem in a different costume. It's all the same underlying pattern. Okay, so that's one pattern down. Let's look at another super common one. Let's move from 1 dimension to 2. Imagine a grid, like a chessboard. You start in the top left corner, and your only legal moves are to go right or to go down. The question? How many different paths can you take to get to the bottom right corner? You guessed it, this is the grid pattern. And look, it's the same core idea as the staircase. The answer for any given square on the grid is just built from its neighbors. The number of ways to get to this square is just the ways you could have gotten to the square above it, plus the ways you could have gotten to the square to its left. It's the same logic, just in 2D. And this simple idea solves tons of problems, like finding paths when there are obstacles, or even something complex like finding the longest common subsequence between 2 strings. So, let's pull back for a second. What's the big takeaway here? We've talked about a problem, a couple of techniques, and a couple of patterns. But honestly, the most important thing, the thing that will change everything for you, is the shift in your mindset. This right here is the whole game. Stop trying to memorize hundreds of specific solutions. That's a losing battle. Instead, train your brain to look at a new problem and ask one question. What is the underlying pattern here? Is this just a staircase problem in disguise? Is this a grid problem? Because once you identify the pattern, you've already won like 90% of the battle. Look, when you focus on these core patterns, you're not just learning how to solve a few puzzles. You're learning a whole new way to think, a system for taking scary, complex problems and breaking them down into simple, repeatable steps. So the final question I want to leave you with isn't about coding at all. It's about perspective. Think about that one complex problem that's been bugging you. Can you look at it differently now? Can you see it not as some unique, terrifying monster, but maybe, just maybe, as another version of a simple pattern you already know how to solve?